written down the 3 states of matter. I see some of you actually literally wrote down 3 states of matter. Now write them down. What are they? That's fine. That's good too. But now write down what they are. All right. Who can tell me one?
Solid.
Solid. Who can tell me another? Liquid.
And
All right. Solid, liquid, and gas. Now let's talk about phase changes. Okay. If we go from a solid to a liquid, that's what?
solid to a liquid. Think of like ice.
Well,
Melting.
well, no, it's a physical change. All right, so somebody said a change. What type of change? It's a physical change, so that's good. All right, but what is the name of that change when we take something? What?
Melting.
Melting, right? So I want you to write down, also in this section, solid to liquid equals melting. Solid to liquid equals melting.
Plus.
Solid
Yeah.
plus a liquid, that's fine. Whatever you want to do.
As long as you understand what it says. I think it's too liquid.
Arrow maybe would be better.
Yeah, arrow would be good. Alright, so we did solid to liquid. What is it if we go from a liquid to a gas? Alright, evaporation. So do the same thing. Alright, so liquid to gas equals evaporation. All right. Now, let's say we go the other way now. All right, so a gas turns to a liquid, that's called what?
Gas.
What'd you guys say? Condensation. Good. Condensation.
You all should
So
know.
write that one down.
I said that.
Gas to liquid equals condensation. What's an example of that? Rain. Okay.
First sign.
Goes from the gas to a liquid.
Clouds.
All right. So what is it called when we go from liquid to solid? All right.
Liquid to a solid.
Freezing. Good.
So what?
Yep.
What is
Liquid to
I
solid.
wish you would have had this.
Freezing.
Remember, you know.
Huh?
No, it's not. It's not. Oh no. Stop recording.
Say what? Oh, I agree. Keep them going. Yeah. that's true. All right. Now, one more thing to ask you. All right. What would it be called if we went from a solid to a gas?
Solid directly to the gas. Just skip it.
You're skipping a phase in there. No idea?
Not evaporation.
Not exactly. Because you have to have a liquid to evaporate.
Solid to gas.
Yeah, vaporization. That's the same thing, right?
Well,
All right, that's a good try. All right, take a look.
You got a different mic?
No, I don't have
we
that.
tried.
Yeah.
We tried.
Drop it off. I dare you to drop it.
All right. So here you go. Here's what I'm talking about. All right. Now listen. Make some careful observations for a second. All right. Somebody's already said it. It's what? Dry ice. All right. It's dry ice. Now, is it normal ice?
no?
What's the difference?
It's,
If I held it with my
hot.
bare hands this long,
It,
yeah,
it
it
can
would've
burn
burned.
you,
All right. So anyway,
and it's made differently.
it's made differently. What do you mean?
Like it, Miss Janicki told me earlier that it could be made with carbon dioxide and compressing something.
All right, compressed gas, right? And then it has to be sent to a very, very cold temperature. All right, way colder than liquid ice, right? All right. So now, what's it doing?
Turning from a solid to a gas.
Turning from a solid to a gas. Now, a little bit odd here, though. What can you tell me about the density of this gas? It is carbon dioxide gas. What about the density of it?
It's not.
It doesn't have.
It's really dense because you can see it even though there's no
Yeah,
snow.
it's seeking
All right. One way you can tell is you can see it. You all are right. It said that. You can see it, which means it's more dense than what? Than the air. But also, it's doing something else compared to the air.
It's falling.
It's falling, right? Now, the normal thing is a gas would do what?
It would go
It
up.
would go up, all right? So this is a pretty dense gas, dense and heavy, right? Meaning that it's falling to the ground. All right.
Is it actually falling or is the less dense air pushing? Or is that a theoretical?
Did y'all hear what he said?
Yeah.
He said, is it falling? Is it actually falling, or is the less dense air pushing it down? What do you think? Both.
I think it's not heavy enough to be severely affected by gravity.
Okay. He said it's not heavy enough to be severely affected by gravity. You got a good point. That makes sense. Need to touch it? Just a minute. All right. What I'm going to do is I'm going to break some of it up. And I'm going to let you have, you should have Petri dishes on the table. You should have one per table. I'll let you make some closer observations.
Yeah. We're learning about it right now. We didn't tell you.
We'll be rushing you to the doctor.
So what would dry ice do if you stuck it in your mouth?
Stick to your tongue and burn your mouth.
Ooh.
I told you to burn yourself. Oh yeah, I like her.
That's epic. Hey, guess what? I'm an airbender. So I guess this is how fog machines sort of work. Oh, crap! Hey, can we get a little bit more water? I think I spilled some.
It's fine.
Airbender. Oh, by the way, that's extremely cold, dude.
You can touch it.
Hey, guess what? This dry ice is really cool. Yes, I had to make at least one lame joke about this experiment.